Audio Jungle. Audio Jungle.
Hello everyone, myself Narendra Singh Maurya. So guys, today we'll solve GATE 2011 jet propulsion problem, right? So here we have problem number 22, and the question is a main objective of bypass in turbofan engine is to increase. Okay, now check. They are talking about turbofan. So here we'll draw this turbofan engine. This is basically turbofan. Okay, engine. Let me complete this. All right, and just simple diagram only I'm drawing. You can relate, that's all. Right? And this is what compressor, this is combustion chamber, this is what turbine, and you just say this is the HPC, high pressure compressor. Okay, better. So this is called low pressure compressor because fan work also to compress the air. So low pressure compressor. This is high pressure compressor. Okay, this is combustion chamber. High pressure compressor is what connected with high pressure turbine, and this low pressure compressor is what connected with low pressure turbine. Okay, you know all that. Hmm? All right, here we have an exit of air, and we have a cowling here. This is called cowling. Okay, what is this called? Cowling. So inside the cowling, we have a fan. So what is the work of this fan? Simple. That work of fan is what whatever the air is what entering here. Check, because they are asking objective. This is what fan. So this fan is what dividing the stream in two parts. Hmm? What are that? First, that air is what passing in this way. Okay, air also. Okay, and this is called cooled nozzle. Why? Because there is no combustion in this cold nozzle, and this stream is called cold stream. What it is called? Cold stream, air. And because here we have a combustion chamber, so in this combustion chamber we are injecting fuel. No, in this combustion chamber, because this is the combustion chamber, so we are injecting fuel here, m dot f, fuel. So we have burning, and definitely we'll have burning, so we'll have a hot air. So the partial part of the air which is entering here, so this will be considered as a hot air. Why hot air? Because in combustion chamber you have burned the fuel. Okay, I'll show by this way. So here this is what hot air. So this is the hot stream. Okay, and this nozzle is called hot nozzle, and obviously in this combined in this combined effect, if you check, okay, this is the hot air, so we will say m dot h, and this is what cooled, so m dot c. But if you overall, if you check m dot c plus m dot h, so what happens here? Now the main objective of bypass in turbofan engine is to increase. What is the bypass ratio? This is m dot c by m dot h. This is called pass ratio. So that bypass ratio is nothing but m dot c by m dot h. So that bypassing means it is dividing the stream in two parts, in cold and hot. And who is doing? By fan. All right. So what is the objective of? To increase mass flow rate through the engine inlet? No, that engine inlet, uh, and that is not the objective of turbofan, to increase mass flow rate. No. Okay. Turbine inlet temperature? No. Mass flow rate through the exhaust nozzle? Compressor pressure ratio. Compressor pressure ratio, definitely it is not. Why? Because that objective of turbofan is what? To divide the stream in two parts, or the bypassing air in hot and cold nozzles. So if you check the exhaust nozzle, we are getting m dot c plus m dot h, means sum of both we are getting. So that mass flow rate here in exhaust nozzle, okay, we can increase with the help of this uh, fan, because there is the limitation of the air passing through the engine. Okay, so that more and more value you cannot increase through the core means through the combustion chamber, compressor and turbine. For that reason, because there is some limitation, so for that reason we are dividing the stream in two parts, so that we can get cold stream also, and finally through the exhaust nozzle we can get more mass flow rate. That is the one reason. Okay, another reason also, like to increase propulsive efficiency, also we are using turbofan, fan engine, or you can say fan. So here among all the four options, what is the correct answer? That mass flow rate through the exhaust nozzle, we are getting mass flow rate m dot c plus m dot h, which is more. Hmm. You can say then, like if even though in propeller also, turboprop engine also, we are getting hot and cold air. That is also true. But there is some aerodynamic limitation, because propeller cannot rotate like beyond the range of the Mach number, because of the separation of the flow and all. But here this fan is what inside the cowling. So still here also there is problem, but compared to turboprop, this problem is what less. They will not get like uh, aerodynamic installation and all early. But in turboprop, early separation of the flow or aerodynamic stalling you can get on the propeller blades. So that is the difference. Okay, so here we, like compared to turboprop and turbofan, we have a that efficient. If you check, that turbofan is what more efficient compared to turboprop in terms of speed and all. Hope you understood this. Done. Now we'll go for next problem. Problem number 23. The pressure ratio in any one of the stage of jet engine compressor is limited by. This is a turbo machine problem, actually, compressor problem. But anyway, we'll try to solve this. Pressure ratio in any one stage of jet engine. So, any one stage of jet engine, what is the pressure ratio, compressor pressure ratio limitation? Pressure ratio in one stage of jet engine compressor. So, they are talking about the pressure ratio in compressor. We have a limitation, they are asking. Why? That option they have given entry stagnation temperature in that stage, entry Mach number in that stage, pressure gradient induced separation in that stage. So option C is correct. Why? Because it's simple. See, so just think in this way. Try to understand. First stage, this is second stage, and this is the third stage. Okay, that air is what moving in this way. All right. Hope you understood. So suppose here at entry of first stage of the compressor, this is the compressor, three stages compressor I'm talking. So easily you can understand three stages compressor. Okay. I told you this is turbo machine question, means compressor turbine question, compressor question basically. So, but it is related to jet engine, so I'm solving in jet propulsion. Otherwise, all the compressor and turbine problems I will solve in turbo machine lectures. All right, session. Anyway, so here, so just say this is what 1 bar. Okay, then in after first stage of the compressor, that pressure is what raised maybe 2 bar. Then again, maybe it is 3.5 bar. Okay, inlet of the second stage is 2 bars, exit of second stage is 3.5, and then inlet of third stage is what 3.5 bar. So exit of third stage is what, just say 7 bar. Just for example, I'm taking. So that pressure is what continuously increasing. So if this is what the length x, okay. So because in terms of pressure, what is the pressure gradient? What is the pressure gradient? Change of pressure, that is dp, in direction of x, that is dx. So this pressure gradient is what? Okay. See, this value is what continuously increasing. So this value is what increasing means what? Means at this point, okay, pressure is what high, and this pressure is what low. This is what high, and this is what low. So flow is what here. Once it was started, because it is moving condition, and fan is what compressor is what sucking air. So here that flow is what entered. Otherwise, flow will always flow from high to low. But here it is reverse, no? Because pressure is what 1 bar, and here it becomes 7 bar. So actually that flow should natural is what? Natural is what from high to low. Okay. So that's the reason pressure gradient induced separation in that stage. So because this pressure gradient means that pressure variation in direction of x. This pressure gradient, because it is going from low to high, so it will try to reverse the flow. Try to reverse the flow. So there is a chance of the separation. Okay. So the for that reason only you have a limitation. Otherwise, you can add like more than 1, 2, 3, 4, 5 up to 10 stage you can go. But you just think in 10 stage and first stage, what will be the biggest pressure difference? You can understand how much pressure burden on the compressor blades. You can think like. So that's the reason you have nominal stages like 2 stage, 3 stage, not 10, 12, 15 stages. Not possible because of the pressure gradient. Because this pressure gradient means that pressure variation in direction x will be increasing continuously, and it will try to reverse the flow. It will try to separate the flow in that stages. Hence, what is the pressure ratio in one stage jet engine compressor is limited. So that limitation is what? Separation. Separation is the limitation or breakdown of the flow. That is called surging. This separation of the flow called is stalling. Okay. So that option also can give, instead of separation, they can give this pressure gradient, because of pressure gradient is stalling. um, Stalling of the stalling occurs in the stages. Okay, the separation of the flow over the blades called stalling. So what is the correct answer? Pressure gradient induced separation in that stages. The answer is C. All right. Now we'll go for next thermodynamic cycle on which jet engine operates can be. This is simple one. It is open Brayton cycle, because jet engine is what works open. What do you mean by open? That it is not recycling the air. I mean, whatever the exit, again you are not going to give to inlet. I will draw the diagram so it will be more clear. Check. Okay, air entry, atmosphere, taking air from atmosphere and exiting to the atmosphere. Again, this is what atmosphere. You are not restyling. I mean that exit you are not taking back to inlet. In case of jet engine, it is possible. No, it is not possible. But ground engine, yeah, that engine like hydraulic engines and all, which is working for ground station. So there you can, there you are using exit fluids. You are again supplying to the inlet of the engine. Yes or no? That you are doing. But for the jet engine, that is not possible because you are taking air from atmosphere and exiting the atmosphere. So that again exit air you are not transferring to the inlet. So that is not possible in jet engine. Hence it is open. This is called open, first of all. And you know very well, jet engine is what always operates at that PV plots. This is what PV plots. So this is the compression. This is what compression. Okay. Then here we have a heat addition. This is what compression or compressor, no? And this is what expansion. This is the expansion, which is nothing but turbine. Expansion and heat addition means what? Combustion chamber. And this is the heat rejection at constant pressure again. So this 1, 2, 3, this is what? Two constant pressure line, 2, 3, and 4, 1. And 1 to 2 and 3 to 4, 2 reversible adiabatic process, compression and expansion. This is what? Brayton cycle. You know very well, this is very basic thermodynamics. So what is the correct answer? Open Brayton cycle only. That's all. Jet engine always works, operates for open Brayton cycle. All right, that is the answer. Done. Now we'll go for the next problem. Problem number 25. They are talking propulsive efficiency of jet engine is. I told you that propulsive efficiency of jet engine is very simple. It was explained. Okay. M dot A, this is what? Exit, and this is what? Aircraft speed or pre-ST. This is what? Intake. This is what? Compressor, combustion chamber, turbine, and this is what? Nozzle. All right. Now, what is the propulsive efficiency? It is nothing but thrust power divided by thrust power plus unutilized kinetic energy. Yes or no? So thrust power is what? Thrust into aircraft speed, TB, T into VA plus unutilized kinetic energy M1 by 2 M dot A VE minus VX. What is VE? Exit velocity to the nozzle. VA, inlet velocity into the diffuser. Inlet velocity of the air, or you can say aircraft speed, meaning is same. So this is the propulsive efficiency. Okay, now we'll go for the question. Directly proportional to both thrust power and air mass flow rate. So you have written here, directly proportional to both thrust and thrust power, okay, directly proportional to thrust power, that is true. But air mass flow rate, where is the air mass flow rate? Here we have air mass flow rate. I will write here. Eta P is directly proportional to thrust power. That is true. And eta P indirectly proportional to m dot A, mass flow rate. You can check. This is wrong. Inversely proportional to both, not inversely proportional to both thrust power and air mass flow rate. This is also not correct. Directly proportional to thrust power and inversely proportional to mass flow. This is correct. What is the correct answer? Option C. Check. Directly proportional to. Okay. Inversely proportional to mass flow rate of air. Hope you understood this. Option C. Now, next question. This is question number 29. Okay. Check. The turbojet powered aircraft is flying at Mach number 0.8 at an altitude. This is what? Sea level. That aircraft is what? Flying here. Okay. Check. Data they have given to you. 10 kilometer altitude from sea level. This is what? Sea level. And here that the inlet and exit area they have given, exhaust gases they have given to you 500 meter per second. Okay. And pressure 600, exhaust gases they have given, and pressure they have given P infinite 60 kPa at this altitude. Free stream pressure means no, exhaust value they have given to you, so it is P exit. P exit is 60 kPa and V exit is 500 meter per second. And the free stream pressure they have given to you here. Free stream pressure means at the same altitude, P infinity they have given how much? 26.5 kPa. Density they have given free stream 0.413 kg per meter cube at the same altitude. And the speed of sound they have given how much? 299. Speed of sound means at this altitude A infinity is given how much? 299.5 meter per. These are the data they have given. First we need to calculate, it is in kilonewtons. Okay. So check. Now all data they have given to us. So simple assembly I will show you. This aircraft is what? Flying. Compressor, combustion chamber, turbine, nozzle we have an exit, and this is diffuser we have an inlet. So at this altitude they have given P infinity how much? 26.5 kPa. And exit they have given PE how much? 60 kPa. And V exit is also how much? 500, no? 500. All right. Now, you know very well, here that mass flow rate they have given m dot A. Check any fuel ratio or fuel mass flow rate they have given. No, they have not given fuel mass flow rate. They have not given fuel mass flow rate. Okay. No. So we'll write the formula for the thrust. So we know total thrust. I must write total thrust. What is the total thrust? It is momentum thrust plus pressure thrust. What is the momentum thrust? Because mass flow rate of fuel they have not given, even fuel air ratio they have not given. So I will write that formula I will write. Okay. So here that it should be m dot a plus m dot f, but they have not given m dot f. We will neglect that. And here velocity of the free stream or aircraft speed is nothing but va or v infinity. It's your choice. So what is the momentum change? Mass flow rate, final mass flow rate into velocity minus initial mass flow rate into velocity. What is the final? M dot A, M dot F, VE minus initial is M dot A into V infinity. This is the I must this is the momentum thrust. Okay, final minus initial momentum. What is the pressure thrust? Exit area you have to take, and exit pressure minus initial pressure will be the pressure thrust. Yes or no? I told you this m dot f they have not given, so you can neglect this. So what you will get m dot a ve minus m dot a into v infinity plus ae pe minus v infinity. All right, this is the total thrust. Done. Now, so this thrust is nothing but m dot ve minus v infinity plus this is the value c exit minus v infinity. What is the mass flow rate at inlet? It is rho inlet area at inlet, okay, into rho av v at inlet. What is the density they have given at inlet? Check. It is 0.413. 0.413. All right. 0.413. What is the inlet area they have given to us? The inlet and exit. Inlet is 0.7. Inlet is 0.7 into what is the velocity at inlet they have given, Mach number they have given, we can calculate. So check at speed of sound they have given, no problem, you can calculate velocity. No? What is the Mach number? M infinity, it is V infinity divided by A infinity. A infinity is speed of sound. What is the V infinity? It is M infinity into A infinity. Okay. So I will write here. What is the V infinity? M infinity into A infinity. What is the M infinity? Or we'll do one thing. We'll calculate this value. So what is V infinity? Wait. M naught is nothing but 0.8 M infinity into A infinity is nothing but speed of sound. How much? 299. 299.5. 239.6. 239.6. I will write here. Okay. What is the M dot A? We got here 239.9.413 into 0.7. So I'm getting 69.26 kg per meter cube. Now we'll write all the value. What is the thrust? 69.26. V exit they have given, I think 500. No? They have given 500 meter per second. keep here minus, just now V infinity you have calculated how much, 239.6 plus exit area I think they have given, check here it is 0.4, take this value 0.4 in bracket, we need to write exit pressure. What is the exit pressure? 60 kPa. What is inlet? 26.5. So 60 kPa, kPa means kilopascal 10 to the power 3 minus 26 point, let me check once, 26.5, 26.5 into 10 to the power. What is the thrust? We need to calculate this. Wait, 69 into bracket 500 minus 239.6 plus 0.4 in bracket 60 10 to the power 3 minus 26.5 10 to the power 3. This value I'm getting here 3143.7.48 Newton, or approximate you can write 31.437 kilonewton. Check. They are asking thrust of the engine in kilonewton they are asking, so better you write only virtual calculator use and write 31.43. This digit you have to fill, that's all. No need to write anything. Hope you understood this solution. Alright, it's very simple only. Just finish within 2-3 minutes. You can finish this problem, no problem. Okay, simple. Now we'll go for the next problem. This is the another problem. Alright, GATE 2011 question number 34. Check. They have given that an engine is operating at a Mach number of 0.8 and altitude of 10 kilometer. The efficiency of the air intake is, okay, intake, now we'll draw the alright, this is what flow here, intake and exit. This part is nothing but intake. This part is nothing but compressor. This is what combustion chamber, or in single word combustor. This is what turbine, you know that, right? And this part is nothing but nozzle. Numbering, very usual numbering, you know that. What is the numbering point? See, this is A, 1, 2, 3, 4, and this is what? Exit. Alright, done. The efficiency of air intake they have given to us. Okay, intake how much? 0.8. And compressor efficiency they have given to us. It is nothing but eta C, compressor. How much? 0.87. The total temperature at the exit of the air intake and compressor respectively. Exit total temperature. What is the intake total temperature? Total temperature at the exit of intake. Exit of intake means, where is the exit of intake? Exit of intake means inlet of compressor. That is T01 total temperature. T01 they are asking, and exit of compressor also they are asking. So exit of compressor means T02. So this two value they are asking to us. They have given ambient pressure, ambient temperature. They have given gamma, PRC. This is the pressure ratio, compressor pressure ratio. Okay. PRC. PRC is the compressor pressure ratio, means P naught 2 by P naught 1. P naught 2 by P naught 1. Check compressor means 2 and 1. So that pressure ratio is P naught 2 by P naught 1. That value they have given to us, which is nothing but 8. This is 8. For this type of question, always you draw, plot, TS plot. So this is what TS plot here, check. So that more clarity you may get. Okay, this is what A, not 1, not 1 dash, not 2, not 2 dash, not 3, not 4, not 4 dash. This is 5, 5 dash, or it is also exit. Okay, so this is what intake, and this is what compressor, combustion chamber, turbine, and nozzle. Okay, so this is what S entropy, and this is what T temperature. So this is what TS plot for the engine. TS plot of jet engine for turbofan. This is for jet engine. I mean turbojet. I'm talking for turbofan. Obviously, two compressor and two turbine will come. High pressure compressor, low pressure compressor, which is fan. Similarly, high pressure turbine and low pressure turbine. For turbofan, separate diagram if you need sometimes. But this is for jet engine. One compressor, one turbine only. Okay. All right. So now they are interested here in T01. They are talking exit of intake. What is the exit of intake? T01. So T01 they are asking. And exit of compressor they are asking, which is nothing but T02. All right. Now we'll go for the calculation T01. Because in intake, no heat addition. So total temperature must be constant. No heat addition, no work. Yes or no? The total temperature must be constant. What is the total temperature? It is A. So at this point, what is the total temperature? T naught A. We must write T naught A. Okay. Total temperature if you say. But inlet I will show A point, which is static. So it means what is the total temperature across intake T naught A and T naught 1, which is constant, because no heat addition, no work in diffuser or intake. T naught A we can calculate. What is T naught A? They have given Mach number to us. T naught A by TA is what? 1 plus gamma minus 1 by 2 m infinity square. 1 plus gamma, it is given, I think, check, 1.4. 1.4 minus 1 divided by 2 into Mach number. What is the Mach number they have pointed? So what is the T naught A? And that value will be T naught. Let me calculate this with calculator. So 1.4 minus 1 by 2, which is nothing but 0.2 into 0.8 square 1 plus 1.182 into TA. What is TA? At this altitude, TA they have given 223.3 Kelvin. 223.3 Kelvin. So 223.3 Kelvin. This is nothing but 251. 251. This is what? Total temperature at the exit of intake. At the exit of intake. Huh? They are asking, see, check total temperature at the exit of intake. Exit of intake is nothing but 1. So here temperature is T01. What you have calculated? 251, I think. Check. 251.88. Check the option. 251.88. 251.88 here and here. Two options they have given. So again, we need to calculate another value so that we can match. 251.88 means 251.9. That is now clear. Now they are asking exit of compressor. Exits of compressor also. What is the exits of compressor? Means T02 we need to calculate. So we'll talk about the compressor. Check compressor. We'll draw the, because compressor efficiency they have given to us. So we'll draw the separator plot for the compressor. Where is the compressor? Check. Compressor is what? Between 1, 2 and 2. So it is nothing but not 1. This is what? Not 2, and this is not 2 dash. This is compressor, okay? So what is the compressor efficiency? It is isentropic temperature or enthalpy rise, no? Temperature rise divided by actual temperature rise. What is the isentropic temperature rise? Check. T02 dash minus T01 divided by actual temperature rise is T02 minus T0. So what we need to calculate exit of compressor is T02. We need to calculate T02 dash we need to calculate. What we'll do? Check. We can write T02 minus T01 is equal to T02 dash minus T01 divided by eta C, compressor efficiency. Okay. What will be T02? T02 will be T01 plus. You can write T02 dash minus T01 divided by eta C. Our headache is T02 dash. We need to eliminate T02 dash anyhow. What is the T02 dash? T02 dash is the temperature, isentropic temperature rise. How to calculate this isentropic temperature rise? For that reason, they have given pressure ratio. Check. Pressure ratio they have given to us. So we can relate that. Yes or no? Now, so we can write this T01 as usual plus we can take T01 common. So we'll have T02 dash divided by T01 by eta C. Okay. What is T02 dash by T01? This is the temperature ratio across the compressor that will be equal to isentropic relation you can use, because this is the isentropic temperature rise. T02 dash is what? T naught 2 dash is what? Isentropic temperature rise. So you can apply isentropic relation, which is nothing but, simple isentropic relation. What is that? You can write T naught 2 dash T naught 1 is equal to T naught 2 dash by T naught 1 to whole power gamma minus 1 by gamma. This is the formula only. This P naught 2 dash by P naught 1 called compressor pressure ratio. What it is called? Compressor pressure ratio, which is also denoted by RPC, that is given. So RPC whole power gamma minus 1 by gamma. What will be T naught 2 dash? It is T naught 1. RPC they have given to us. How much? PRC or RPC? 8. Pressure ratio. This is RPC or PRC. R means that ratio of the P means pressure, C means compressor. So compressor pressure ratio, that's the mean of it. Many books you may get RPC, or here it is given PRC. So don't get confused. That meaning is same. Okay. This value they have given how much? Once again I need to check. It is 8. It is 8. 1.4 minus 1 divided by 1.4. T naught 2 dash. T naught 1 you have now. How much? You have calculated here. It is 251.88. I will write 251 point. In fact, no need to calculate this T naught 2 dash. We have to calculate this value only because we need to keep that value, no? T naught 2 dash by T naught 1. Yes, that ratio we need to keep. No need to calculate this T naught 2 dash. Sorry, let me. Sorry, this is not required. Unnecessary T naught 2 dash, because we need to calculate T naught 2, not T naught 2 dash. We need to calculate T naught 2. So for calculation of T naught 2, we need T naught 2 dash by T naught 1. Hence, we need to calculate only T naught 2 dash by T naught 1. So this value we need to write 8 to whole power. This is what? 1.4 minus 1 divided by 1.4. How much? Let me calculate. No. Anyway, so 1.4 minus 1 divided by 1.4, and then 8. We have 8 here. This is power 1.811. Okay. T naught 2 dash by T naught 1. This is the value. Now here you can keep. So what is the T naught 2? Check. T naught 2 is nothing but T naught 1 plus, what is the formula? Here you have written T naught 1 in bracket, it was T naught 1 251.88. 251.88 plus 251.88, and this T naught 2 dash by T naught 1 value 1.811 minus 1. Okay. Divide by eta C. Check compressor efficiency, how much it is given? It is 0.87. It is. So what is T naught 2? Need to calculate. Wait, I will do this. Minus 1.88 minus 1 into 251.88 divide by 0.87 plus 251.88, 486. 486.80 Kelvin. This is T02. All right. So we have T02 486 and T01 251.88. Check. 486, this is the correct answer then. What is your answer? Answer is C. I hope you understood. So all the steps here I have done. Now you hope understood this problem. So you like and subscribe the channel. Keep doing hard work. Thank you. Thank you all. Thank you so much.